I turn an x squared into a 5x to the 4th? We multiply it by? Good. And where do we place that? Above this x squared. So 5x squared. Distribute through, and we get the 5x squared, 15x cubed, and 0x squared. Subtract them out. Oh yeah, thank you. And then you wind up with a negative 1x cubed, 0x squared, and a 9. What do you multiply x squared by negative x cubed? Is it okay if I write negative 1x? Thank you. And then we have a 0. Okay. Subtract out again. We get 3x squared plus 9x plus a 0. And then we're in step done. What's up? You missed the negative on the second one. And then you wind up with a 3x squared, 9x, and you have a 0 remaining. Okay. That's usually the goofiest as this stuff gets when you have, as you're multiplying these things out, because you have all these extra placeholders, to be honest with you. What's up? No. Nope, you don't have to. What's up? That's fine. Let's see. Which one? 29. Okay. So here, it doesn't necessarily mean you're going to get a 0. You could just get some number. All right. Today we'll be focusing more on wanting to get a 0 at the end. Okay. So here we have 4x squared, 5x minus 4. You're using synthetic division. You have a second degree polynomial, which means how many terms should you have in your 3 of them, which we have all 3. If my term, remember, terms that are in parentheses, they generate zeros. The 0 for x plus 1 is negative 1. So we divide by our negative 1. Synthetically, we have a 4, 5, and a negative 4. First step, synthetic division. Drop the 4. So far today, people that are screwing up synthetic stuff, they're writing down in that first thing, negative 4. Or in some of the other ones, people are, if it's like a 2 out front, they're putting it as 8. They're forgetting that you just literally dropped that first term. Then you get a negative 4 here. Excuse me, gives me a 1, gives me a negative 1, which gives me a negative 5. And that's fine. There's nothing wrong with it. Just what this means is that x plus 1 is not a term of 4x squared plus 5x minus 4. All you're doing is just getting the practice on synthetic. Yes, ma'am. Yes, you'd be done with that. The reason that we talk about it in terms of saying that x plus 1 is not a term for it, because it doesn't end up as a true 0. If negative 1 was a 0, that meant that I could have factored out the x plus 1. And that's kind of what we're getting towards today. A lot of the stuff you did last night, or over the weekend, or first thing this morning, or last hour during flex, that you were just kind of going through the process, just remembering how to do that. Okay. Better, you had something? Never mind, I didn't want to help. Make sure your name's on it, send it up. Let's talk a little bit about the last bit of this. Then we'll get into this. Okay. When we did that the other day, we're not So you're just practicing your real synthetic. What's the wrong way? The wrong way. Thank you. Why are you so grumpy? What's up? All right. So here's where this is all getting us to. What we were just talking about a second ago, we were saying that, remember I said that x plus 1 was not a term for it? Yes, ma'am. Oh. We said that x plus 1 was not a term because it didn't end as a 0 when you divided out. So as you get into this stuff, if you know that you have a 0 to begin with, you know that it has a term that can be factored out. So in this case, they're telling me that f of -3 is 0, which means -3 is a 0 of the function. If -3 is a 0 of the function, what's its term? X plus 3. Okay. So remember, zeros generate terms, terms generate zeros. They go back and forth. That's all the while we've been doing this. I put my hands up when I say terms. Have you ever noticed that? It makes a parentheses. I like air quotes, Shifty's cool. So this is where synthetic division becomes your best friend. If you know that -3 is a 0, we have a polynomial, 2x cubed plus 11x squared plus 18x plus 9. When we had a third degree polynomial before, it had 4 terms. In this case, it does have all 4 terms. You don't have to have placeholders. We would try to factor that via grouping. Remember how we did that? Now, if you look at it and you try to factor this one via grouping, you'd only be able to take out an x squared, you get a 2x plus 11. Here you take out a 9 and you get 2x plus 1. Last I checked, 11 and 1 are not the same number, which meant that you were not able to factor this any further. You couldn't do anything about it. You guys would have said, nope, can't factor it, and you go to the next problem. Well, what synthetic division allows us to be able to do is find those weird values that make things factorable. So pull out your coefficients like we did before. We get 2, 11, 18, and 9. Drop the 2 and you get 2. -3 times 2 is -6 and 11. -3 times 5. -15 and 18. -3 times 3. You get a 0, which is convenient because it told you it was a 0. I know, right? So who would have thunk it? Now remember I was doing that sometimes by saying, hey, that's a 0. So we circled it because it makes it look like a 0. Now, if that's a 0 at -3, what's its term? Okay, so you get x plus 3 was able to factor out of something, which means what's left inside there is, remember when we factor something out, we drop a degree? That means our new coefficients are 2x squared, 5x plus 3, which therefore means I can factor that further. What times what is 6? You add together to get 5. 2 and 3, right? So this becomes 2x squared, 2x, 3x, and a 3. Oops. All the while the x plus 3 is here. What we're doing is when we have a trinomial quadratic, if you will, that has a leading term that's not equal to 1, remember we multiplied our tails to get to the middle? It was that way of doing that factor via grouping, split middle term, however you want to call it. And again, you're taking GCFs. What's the GCF of that first group? 2x. So we have a 2x, then I'm left with an x plus 1. GCF in here is 3. I have an x plus 1. Now, are the two things that are in parentheses the same thing? Yeah. So we write it down. We have an x plus 3, x plus 1, and what's left over? Very good. Yep. So that means that we just factored that that polynomial, the third degree polynomial that we only knew we had 1 0 of, and we got all the rest of it. So we knew we had a 0 at -3. These are my factors generating zeros of -3, -1, and -3 halves. What are your tails, Nancy? Down up. So these are down up, and if I wanted to, these are going to be down up, and if I wanted to graph via my tails and my zeros, so here's 1, -1, here's -1.5, here's -3. Not drawn to scale. There you go. Okay. It all comes back. We have a third degree polynomial, 4 terms, 3 possible zeros, 2 changes in directions, and so on and so on and so on. We should make like a partridge in a pear tree song on it. 5 changes in directions, 4 possible turns, 3 zeros. Murphy's fell on his head as a small child. Doesn't know what he's talking about. And let's factor the rest of this function. Yeah! So let's try it again. X cubed minus 2x squared minus 9x plus 18. And again, they write it out. Sometimes they write it a little bit differently about how your zeros are. They'll say one of the zeros is x equals 2. Earlier it said f of, -3 was 0. Sometimes it'll say a 0 is 2. They just write it differently. So I have a 0 at 2. I have a polynomial function of x cubed minus 2x squared minus 9x plus 18. You could probably say right now that you could group this one because you can probably see that you've got GCFs and it would work out pretty cleanly. Honestly, I would, if I knew that I just had to find zeros, I would have recognized that and just done that first. But this is another way of doing it, so that way, when you can't do the grouping, you can always fall back to synthetic. So we go with our 0. Coefficients, 1, -2, -9, and an 18. First thing you do is bring down the 1. All right. Whew. 2 times 1. Open your calculator up, lady. -2 plus 2. Get your calculator up. 2 times 0, which therefore means you have a 0 at 2, which makes your term x minus 2. And then in here you get, yes ma'am? Yeah, because eventually you're not going to know what this is to start. Yeah, eventually, but you don't know, if you know x minus 2 is one of the terms, what's the other one? Well, you can do it via like long division if you want. But I know you're getting at. There are different, I mean, when you get into these things, there are some ways that are quicker than others. Yeah, if I see this one, I had to find all my zeros, I just factor. I prove it. It's quicker. But this is, like you said, it's reinforcing how it works. If I'm just trying to find zeros, do I need to factor that any further? No. If I did have to factor, if it's just said factor completely, what would be my last line? Bless you. And this one, I think it's just said find all the zeros. All my zeros then would be at 2 and plus or minus 3. What are your tails dancing? Which is it? Which way, though? We don't say it that way. Down, up. Read from left to right. That way it's down. I know you were pointing it, but other people don't understand you. Yes, this is your left hand, right? There's a couple of ways of doing it, because what happens eventually here, guys, let's see if I have it over. What's going to happen here in a day or so, I don't know if we'll get to this tomorrow or not. Guys. Yes, sir. Yeah. When she gets back, she's out. Don't write this out yet, but what's going to happen here in a little bit is that you're going to have something like this where we have a fourth degree polynomial. It can be any degree, it doesn't matter. We know that a fourth degree polynomial can have up to how many zeros? We have 4 of them. How many changes of direction can the graph have? 3 of them. How many terms in the sequence? There's your 5. All right. Now, we know by looking at this what the tails are doing. It was 10x to the 4th. What are the tails doing? They're up, okay? So, but if I'm looking at this with 5 terms, I can't group anything. I can't do anything like that. So in order to factor this, I have to be able to do something with the zeros. So knowing what a zero generates, remember, zeros generate terms. If you can get a 0 out, you're dropping your degrees into something more useful. But if we don't know where to start, that's what gets weird. Okay? We'll get to that, but it all comes with factors. What are all the possible factors of 12? 1, 2, 3, 4, 6, and 12. Okay? And the reason I wrote plus minus is because it's a positive. I can take -1 times -12, and I can get 12. 2 positives, 2 negatives. What are your factors of 10? Which basically means you have possible zeros that you can find. We'll get why this works at plus or minus 1. What did that be? 1, 2, 3, 4, 6, 12. 1/2. 3/2. 4/2 is 3. 6/2 is, 4/2 is 2. 6/2 is 3. 12/2 is 6. 1/5. What I'm getting at is, as you guys have noticed, synthetic division is pretty quick, isn't it? What's going to happen here as we get into why all this works, which I don't think I'm just going to stop here at this, is because when you don't know where to start, you got to figure out where to start. So what we're doing here is we're searching for what could be possible zeros. So you would start at one of them and go through the synthetic division. If you end in a 0, great. You factored out your first term, and then you start over. If you don't end in a 0, you erase it and you pick another number. That's why I kind of joked saying I should send out an email over break saying make sure you buy an eraser. You will do a lot of erasing in this next unit here. So why don't you guys take a minute, factor these two out completely, giving me all zeros for these two polynomials. They gave you a 0 for both of them. They're nice today. So you're given 1 0. I'm going to ask that you find all the other possible zeros. Okay. And ask you. So with any luck, you guys figured out real quick that they're pretty fast. You have 4 as a 0, 1, -8, 4, 48. So, guys, if you don't get 0 here, and they told you that it is a 0, you know, yeah, they're wrong. You've done goofed. Refigure it out, Usually it's because you wrote this wrong. That's a trick question, right? So that gives you an x minus 4. Remember, every time you factor something out, you're dropping 1 degree. If you took out an x from an x cubed, it becomes an x squared. So this becomes x squared minus 4x minus 12. What times what's 12? You add together to get negative 4. Yep. So you have x minus 4, x minus 6, x plus 2. That's fully factored form. Then the next step would be then to get all the zeros. Your zeros are at 4, 6, negative 2. What are your tails doing? They're going crazy, but they're going down up. They're a little crazy in the middle, but on the ends it's doing that. And go from there. Okay? Next one, same deal. We have a 10, 2, negative 14, negative 56, and then negative 40. 2, 20, 6, 60, 4, 40, and a 0. Gives you a 0 at 10. And a lot of you guys that I've wandered around already saw this trick here. Instead of trying to factor that out the way it is, 2x squared plus 6x plus 4, they all have a GCF. Factor out the 2 right away. If you factor out the 2, yep. It's just quicker now. Because you have a GCF of a 2. What times what's 2? You add together to get 3. 2 and 1. So we get 2, x minus 10, x plus 2, x plus 1. Now in terms of the zeros are concerned, that GCF, that factor, that multiplier, if you will, of 2, has no bearing upon the problem whatsoever. So our zeros will still just be located at 10, negative 2, and negative 1. Okay. Factoring this way is going to be, or will become your best friend. Because you can take these god-awful polynomials. If you know a starting place with a starting 0, it goes by super, super fast. Okay? ¿Más preguntas?
No.
Qué bueno. La ventanas. La puerta. Es un reloj. Hola, Devin. Oh, he's facing the wall. I'm sorry. You don't have to stare at a wall. We're really here. Say hi to everybody. I can't hear you. Say hi again. All right, let me give you some homework.
What?
If I'm not mistaken, ladies and gentlemen, if I'm not mistaken, I think I told you first hour. It's the same section, it's the next page over. I want you to know it was evens. It was evens.
I like evens better than that.
It's the evens, the 40 through 56 evens. On just the next page. It's still 6 files. The PDF file is on there for you. It's just the next page over. The first 4 of them are factors given that give you a 0. The next one it says given 1 0, find all the other zeros. So basically, the first one you're just factoring. The second one you're factoring and writing down zeros. Okay. And then we'll go from there. Tomorrow I'll probably do a little bit more of the same. I don't see us getting too far out of this because
if we get into anything newer, you're just forget all about it. You're going to forget all about it over break anyway and have to reteach it. So I just keep it the easy stuff is the okay? I think